Good afternoon, dear students. Today we will discuss about the remaining part of syntax analyzer. Within that, we already started discussion on what is context-free grammar. Today we will be discuss in depth about the derivation, and we will take what are the different types of derivation, and we will take example to identify what is leftmost derivation and what is rightmost derivation. And at the same time, we realize them with the help of an example. I am Dr. Sudarshan Behra, working as an assistant professor in SR University, Warangal, Department of Computer Science and Engineering, in the School of Computer Science and Artificial Intelligence. So yesterday we came to know what is context-free grammar, the formal definition, and what is derivation. We got the definition of derivation. Then today we'll discuss what are the types of derivation available, and we'll take example to realize their to realize how they are different from one another. Okay. As we discussed yesterday, derivation is the process of generating string from the start symbol of the grammar by subsequent replacement or substitution. Okay. So that is called as derivation. This derivation is of two types. Here you can see this is the definition of derivation. A derivation shows how strings can be generated from the start symbol of the grammar by repeatedly applying production rules. This one I just want to modify a little. A derivation is the process of generating string from the start symbol of the grammar by applying subsequent substitution. Okay, subsequent substitution by using the production rules. Subsequent substitution in the sense what? In the production rule is of two types. It has two parts. One is the left side, another one is the right side. Okay, left side is as per the context-free grammar is constant. Left side must be contain exactly one variable. So left side of a production or left side of a derivation in context-free grammar is always contains one single variable or non-terminal. Whereas the right side of a production, it may contains any number of terminals, non-terminals, or any combination of them, right? So it may contains null string also. So here one example is given. You try to understand. Consider this grammar where it has two production. S derive A, small a, capital S followed by small b, or this vertical bar indicates or. Okay, you may write them in two different steps. Okay, S derive small a followed by capital S followed by b. This is one production. Second production, you may write capital S derive AB. Okay, that is your second production. So instead of writing them, one after another, okay, here the author suggested one very nice mechanism to write them in a single line, but whenever you are using a bar, vertical bar, it indicates that there are two productions. S has two productions. Okay, one is A, S, B, and the other one is AB. Okay, this is also one way of writing the productions. Here S is the start symbol of the grammar because we came to know that context-free grammar has four parts. Okay, STPS or VTP. You can write VTPS or NTPS. Yesterday I told. Okay, what is B? B is the set of non-terminals. And what is T? T or sigma is a set of terminal symbols. Then what is P? P is the set of production rules. And what is S? S is the start symbol. Here S is given start symbol, and it has two production, P1 and P2. What is P1? P1 is S derive A S B, whereas P2 is S derive A. Right? To generate the string triple A followed by triple B, the derivation process can be written like this. Can be written as follows. So first, as the derivation always start from the starting symbol of the grammar. So S is the start symbol of the grammar. Okay, S is the start symbol of the grammar. So S derive A S B. How can you generate that many number of A's and B's? Because if you replace the right hand side of the production with the right hand side of the production, then only that many number of A's and B's can be possible. So here what the author has done, you see. So here S is the start symbol of the grammar. So S is obviously S has taken into consideration first. So S has the production A S B. Then within that right hand side, yes, is again a non-terminal. And what is the value of how many productions are available for S? Two production again A S B and A B. So this right hand side S is again replaced with itself, because it is a non-terminal and it has a production. So non-terminal can be replaced by itself also. Okay. So this non-terminal, this is called as a recursive function. Okay. It is a kind of a recursive function. The function which which call itself. That is called as a recursive function. So this variable or non-terminal is also a recursive nature, because it replaces itself. It call itself. Okay. So here previous A is as it is, previous B is as it is, middle S is again expanded as A S B, because that is the production of this. Okay, again in the third part. So you see, now you need how many number of A's and B's are given? 3 A's and 3 B's. Okay, but here you got so far 2 S followed by capital S followed by 2 B's. Now you think which will be the suitable production you can pick or you can choose, so that you can get the desired string. There is a production, S has a production, S derive AB. So if you place that AB here, okay, you will get triple S followed by triple S, right? So S is got replaced with AB. So you got triple S followed by triple S. Thus the grammar successfully generates the required string. Okay. So this process is called as derivation. This process is called as derivation. Okay, replacing the right hand side of a variable with replacing the right hand side of a production with its left hand side is called as substitution. Okay, just replacement. Okay, so in this way you see the entire string got derived from the given grammar. Okay, this is called as derivation. This process is called as derivation, and for this you can easily construct a tree also. Okay, S has 3 children, A capital S B. Then the first leftmost child is small a as it is. Next the middle child S is again divided as A S B. So finally that middle S again can be replaced by A B. So you got A B B, triple S followed by the string got generated. The same thing can be diagrammatically represented, and if you diagrammatically represent it, it will be known as derivation tree or syntax tree. Okay. Let us see the types of derivation. There are two types of derivation, as you can see in the screen. There are two types of derivation. One is leftmost derivation, another one is rightmost derivation. Okay, first one is leftmost derivation, and second one is rightmost derivation. What is leftmost derivation? In a leftmost derivation, the leftmost non-terminal is replaced every time. Okay, if in the derivation process, Okay, if in the remember what I'm saying, if in the derivation process the leftmost non-terminal in the right hand side of the production, not the left side. Okay, right hand side in the sense this production generate the sentence, so that is called a sentential form. Okay, or you may write like this in a sentential form. If every time the leftmost variable get replaced, okay, until the actual sentence seen, that is called as leftmost derivation. Okay, or the leftmost in a leftmost derivation, the leftmost non-terminal is replaced first every step. Okay, or you may write like this: if in a leftmost derivation, the leftmost non-terminal is always get replaced. Very simple. Okay, not the rightmost non-terminal. Okay, if in the derivation process the leftmost non-terminal is always replaced, that is called as leftmost derivation. Okay, for example, S derive A S B, and now S derive A capital. This middle S is got expanded as A S B B. Finally, this S is got replaced with AB, as we have seen this example previously. Okay, so here at every stage you see the leftmost S. In the right hand side, how many non-terminals are there? Only one non-terminal, that is S. So that will be by default treated as leftmost non-terminal. Okay, because the nature of compiler is to scan the source code or to read the source code from left to right. So that is why if single non-terminal is there, so by default it will be considered as a leftmost non-terminal. So you see in the first derivation, in the first production, the S is expanded as ASB, and finally that S is got replaced with AB. Okay, so this type of derivation is called as leftmost derivation. Okay, same example we will see for the rightmost derivation. In a rightmost derivation, the rightmost non-terminal is replaced first at every step. Okay, here as single variable, if you consider this single variable as a rightmost variable, okay, then if you expand it, this S get replaced with ASB, and then finally S get replaced with AB, and finally you got 3S followed by 3. Okay, in this example, I think you got a little bit doubt because same variable got replaced. Both same variable is taken as a leftmost variable and a rightmost variable. So that is why I'll give you another example where your doubt will be clear. Okay, but this is also one very tricky question. You try to understand here. If the question will come find out the leftmost derivation, don't confuse. Only one variable is there. I have to take it left. At that time, you consider that the variable is leftmost variable. If rightmost derivation is asked, at that time you can show it as a rightmost variable. Okay. Now to give you a clear picture, I came with a second example. Okay. Let us go for this. And yeah, this is the parse tree. For either for leftmost derivation or rightmost derivation, this is the parse tree. First, S is expanded as ASB. Then this S is again expanded as ASB. And finally, S is expanded as AB. And if you see the leaf node, every time A, followed by B, B. Because how we are traversing the tree? We traverse the tree from left to right. So first, starting from root, you come to the leftmost child, that is small a. Then you come to the next next interior node, that is capital S. In that interior node, visit the leftmost child, that is A. So now you got 2S, and finally you visit the leftmost child of S, that is 3. That is another A. So you got here 3S. Similarly, on the right hand side, 3Bs. Okay, so your string got generated. Okay, so this thing I came with a second example where your doubt will be clear. You can easily understand I mean, there will be no doubt if you see that example. Okay, you can easily say what is leftmost. You can easily classify what is leftmost derivation and what is rightmost. Here you see, this is one of the famous example, okay, where you can easily understand what is leftmost derivation and rightmost derivation. This grammar is particularly made for arithmetic expression, okay. It used to solve the arithmetic expression in a compiler, okay. So you first read the grammar once. The grammar has three productions actually given, three productions, okay. One is E derive E plus E. Second production is that is P1. You can consider P1. Production 1 is E derive E plus E. Production P2 is E derive E into E. And production P3 is E derive identifier ID. Identifier, in short, it is written on ID. Where identifier can be anything. You can take identifier as A. You can take identifier as B. You can take identifier as sum. You can take identifier as C. You can take identifier as initial. You can consider it as a sum underscore 05. Anything can be considered as, anything that obeys the rules of identifier can be considered as identifier. Okay. So here three productions are given. And what is the start symbol of the grammar here is E. And how many non-terminals present? Only one non-terminal present here. That is E. And how many terminals present? One is plus, one is into, because they are operators, I told you. Operators, identifiers, small case letters, okay, and special symbols. These all are comes under terminals, okay. So plus is a terminal symbol, into is a terminal symbol, and ID is another terminal symbol, right? And what is the target string? The target string is ID plus ID into ID. So for this grammar, the compiler or the syntax analyzer has been asked to generate the string or to check the validity of the string ID plus ID into ID. That means it is a task given to the syntax analyzer that this is the string given, this is the target string. You try to generate the target string from the given grammar. If you can able to generate the target string, okay, so then the string is correct, grammatically correct, syntactically correct. If you are not able to generate the string from the given grammar, then there must be some mistake in the string. Then the string is grammatically ill. Okay. So this is the target string given. Now let us go for first leftmost derivation and the corresponding tree. I mean derivation tree or parse tree. Then go for rightmost derivation. Try to understand what is rightmost derivation and the corresponding. So it is leftmost derivation. In leftmost derivation, the left, as I said before, the leftmost derivation, in the leftmost derivation, the leftmost non-terminal always replaced first. In every step, the leftmost non-terminal get replaced. So you start, here is the derivation steps given, and the right hand side, the explanation also given for your better understanding. Okay. So what is the start symbol of the grammar here? The start symbol is E. So E derive, you can take any one. E has two productions, three production. E derive E plus E, one production. Then E derive E into E, another production. E derive ID, another. So you can choose a suitable production, either E into E or E plus E, so that you can start. Okay, so that you can start targeting the desired string, right? So here E derive E plus E. The start symbol E is expanded by its production or by the rule E derive E plus E. So now the start symbol E is recognized as E plus E, first derivation. Okay. Then what in the right hand side, how many variables are there? No doubt the variable is identical, but how many times it is repeated? Two times. One is E plus then E. So if you scan, the first E will appear. The leftmost E is first one, and the rightmost E is the second E. Okay. So as it is leftmost derivation, you always try to expand the or always try to replace the leftmost variable. So leftmost E, here leftmost E is E that can be replaced with its production ID, because E has a production, we have already seen here, you see the third line, E has another production E derive ID. Okay, so here the leftmost E is first replaced with ID. So replace the leftmost E with ID. This is the explanation. Because first E is the leftmost variable. Okay, by leaving that, you cannot come to the next string. Okay, or you cannot scan the rest of the things. Okay, so first grammatical grammar symbol that is a non-terminal, that is the leftmost E, that has to be expanded first. Expanded in the sense that it can be replaced with its child or with its production. That is called as expansion, replacement, substitution. Okay. So first E is replaced with ID. Now the entire sentence is ID plus capital E. Okay, ID is a terminal. You cannot break it. Plus is a terminal. You cannot expand it. Then the remaining E is the last E. So in this sentence, how many capital E's are there? Only one. So if you go from left to right, so that will be the only E which is present in the left hand side. Okay. So now you replace that E. So first ID plus, now this E is again expanded as E into E. Otherwise, if you replace it with ID, you cannot get your desired string. Your string has three operands: ID plus ID into ID. But if you stop this E as if you replace this E as with a wrong production, if you replace this E as ID, then total string you will get ID plus ID. Where is the another part? Into ID. You cannot get the target string, right? So in order to get the target string, here you need to spend little time. Here you need to choose what will be the right production I have to take so that I can reach to the target string. That is the tricky of this particular syntax analysis. So this selecting the right production is the task of a top-down parser or bottom-up. Okay, that we'll be discussing in the next class. But here I am telling you, here as a human being, you can see, you can select, yes, earlier I took E as E plus E and I got ID plus, and here another last E, if I will get ID, then my string will be ID plus ID. I may not reach to the target string. So I, instead of taking E as ID, let me take E as E into E. So next step, E got replaced, that is the leftmost E. Because when there is a single E, you can say it by default, you can consider it leftmost E. Okay, so this E is got replaced with E because you are traversing from left to right. Okay, so E into E. Replace the leftmost remaining E with E into E. Yes, that is got replaced. Now, what is the sentence you got? ID plus E into E. Now again, how many E's are there? Capital E is 2. Okay, ID plus, after that, the immediate E is the leftmost E. So replace it with the right production. What will be the right production do you like to choose? Here ID. Here, if you choose ID, then you will get the string, your string becomes ID plus ID into capital E. Okay, into capital E. So this capital E, again, you can treat it as a leftmost E, and this you can replace it with ID, because you cannot again further expand it. You can do that. You can further expand it E as E plus E or E as E into E. But if you do that, can you get the desired string, your target string? No, you can get something beyond that. I mean, more than that. The number of operands will be more than that. But in your target string, only 3 operands are there: ID, ID, ID. ID plus ID into ID. How many operators? 2. How many operands? 3. So in order to get those 3 operands, okay, and 2 operators, here you got ID plus ID, you already got. Now into E, that E need to be replaced by ID. Okay, because E has a production called as E has a production called as E derive ID, right? So that is the production you choose, and here you got the final string ID plus ID into ID. You see the target string given in the question. The target string was ID plus ID into ID. ID plus ID into ID, and what you got here? ID plus ID into ID. Okay, so this is the final. You cannot now. Everything is in terminal, and terminal does not have production. So no need to expand, and no, you cannot do any expansion for the terminal because they don't have production. Terminal nothing but the input tool. So now what you did in the derivation process, same same thing. You just draw diagrammatically. Okay, first, what is the root? What is the start symbol? Start symbol is E. So the tree of the root of the tree will be E. So E got expanded as E plus E. So here you expanded tree E plus E. Now the leftmost E got expanded, got replaced with ID. So E got replaced with ID. Then plus is as it is. Then third E is replaced with E into E. Yes, you kept it E into E. Then among those, now E into E. Now in that, you got a new E. I mean, you got two new E's, capital E's. One is left side, another one is right side of the into operator. So now first you expand the left side E, which is present left to the into operator. So that is got expanded as ID, and finally the third E got expanded as ID. So ID, if you traverse the tree, ID plus ID into ID. So yes, you got the string, right? So this is your leftmost derivation. If every time the left hand side of the leftmost variable get replaced, that is called as leftmost derivation. Same thing you can realize in rightmost derivation. Now see, rightmost derivation. If every time in the derivation process the rightmost non-terminal get replaced, okay, that is called as rightmost derivation. Okay, so here you take the same production. You can take E derive E plus E. Now how many E's are there in the right hand side? Two E's. One is E plus and E. Among them, which one is the E which is comes after the plus symbol is known as right side, rightmost E, because we traverse from left to right. So here first E, then plus, then another E. So this another E, last E will be treated as the rightmost E because that is appear in my right side, right? So that is called as rightmost E. So that E will be need to be expanded first. So you see, you started with the same production E derive E plus E, then rightmost E is there, E plus is there as it is. The rightmost E got expanded as E into E. Here you see the rightmost E got expanded as E into E. Now again, now you have three E's are there. So you got the full expression, but only replacement is left. So substitution is left. But three is full expression you got here. E plus E into E. So which one is the rightmost E? The third E is the rightmost E. So you replaced it with ID. Now you got E plus E into ID. Now you have two E's left. One is the first E, first, then plus, then second E, then into, then ID. Okay, into ID. Before that, the middle E now will be treated because if you comes from left to right, the middle E will be treated as rightmost E, because after that there will be no non-terminal called as E. Okay, or no other non-terminals also present. So that leftmost E, sorry, the middle E is nothing but the rightmost E. So now you break that or replace it or substitute it with its production. What is the production? E derive ID. That is the production. So now that E, middle E got replaced with ID. Now the total sentence you see E plus ID into ID. So then how many, everything is terminal except one E. One E means when you come to write the first E, okay, you may consider it rightmost E or leftmost E, no problem, because there is no other E, only single E is there. Okay, so you replace it with the ID. Okay, replace the rightmost E with ID. Okay, so that E is replaced with ID, and finally you got ID plus ID into ID, because there was single E, right? Single E plus ID into ID. So if single is there, single E is there, if you traverse from left to right, you can consider it as a rightmost E only. Only single E was there, no? So so you can consider it as a rightmost E. So you can replace it by ID, because your target is to replace from right side. Okay, if you're scanning like this, but you are coming like this, you're coming like this. Okay, replacement is from right to left. Okay, but your reading is from left to right, but the replacement is from right to left. So that leftmost E, now as the replace process is right to left, will automatically treat it as rightmost variable, and it is get replaced with ID. So finally what you got, ID plus ID into ID. Same thing is depicted in the diagram also. So first started from E, E derive E plus E. Okay, then the rightmost is got expanded as E into E. Okay, and in that the final last E is got replaced with ID. Then the middle E got replaced with ID, and finally the last E got replaced with ID. If you see the trees, both the trees are generating. Okay, both the trees are looking same. Okay, they looks alike, and they generate the same string. Okay, understood? This is called as rightmost derivation. Why they generate the same string? Because this particular grammar is known as ambiguous grammar. That is why both the trees are looks alike. Okay. If you take some other grammar, then the tree may vary. Rightmost derivation tree can be looks differently from the leftmost derivation. Okay. Now the next topic is ambiguous grammar. The same example I took here. Okay, just to clear your doubt, what is an ambiguous grammar? A grammar is said to be ambiguous if it has more than one leftmost derivation or more than one rightmost derivation for the same string. Try to understand. If it has more than one leftmost derivation or more than one rightmost derivation, then such grammar is called as ambiguous grammar. Okay, you at present you read this example, same example we took here. Three productions, E derive E plus E, then E derive E into E, and E derive ID. The grammar can generate multiple parse tree. Multiple parse tree. A grammar which can generate multiple parse tree for the same derivation, for leftmost derivation as well as for rightmost derivation. Okay. Or you may say the grammar which can generate, actually this is which can produce more than one parse tree or more than one leftmost or rightmost derivation. Such grammar is called as ambiguous grammar. I am giving you clear-cut explanation, the clear-cut definition. Any grammar, okay, any grammar which produce more than one leftmost derivation or more than one rightmost derivation for a particular string, that grammar is called as ambiguous grammar for that string. Okay. Ambiguous grammar create confusion, because if I'll send you go to block one and get my books. Okay, while going, if you encounter two path. Okay, two path. Okay, there is a some, let us say there is a circle. From that circle you got two paths, so connecting to block one. Then and both the path may spend may take, I mean you may spend equal times. If you prefer either of them, then definitely you will think, while which path I have to take, whether this path I can reach block one, or through this path I can reach block. So that is called as confusion. That is called as ambiguous. Okay, that such kind of grammar leads the compiler or makes the compiler confusion, or yeah, it leads the compiler to be in ambiguous nature. Okay, so this kind of, it is already observed. So that is why, okay, while designing syntax analyzer, this ambiguous grammar has avoided. I mean, now I can say that there is no parser, I mean top-down parser or bottom-up parser. There is no parser which accept ambiguous grammar or which works with ambiguous grammar. Okay, because many occurrences has been observed, many instances has been observed that ambiguous grammar leads the system or leads the scanner or leads the compiler into confusion. Okay, so that is why ambiguous grammar is not accepted by any kind of syntax analysis. Okay, neither by bottom up nor by top down person. Okay, so if there is ambiguous grammar and if you want to work with that, or if you want to design syntax analyzer, so you have to make the grammar free from ambiguous nature. Okay, that you have to make that grammar free, I mean unambiguous. You have to convert the grammar into unambiguous. Then you can feed them into the syntax analyzer or to the parser, either bottom up or top down. Okay. So here is an expression. Okay, here is the expression ID as previously seen, ID plus ID into ID. This expression can be interpreted into two ways. One is ID plus ID. I mean, first addition will be takes place, then multiplication, or first multiplication will take place, then addition. Okay, so the path are same. Okay, since the same expression generate multiple parse tree, so here multiple parse tree can be present. If you take rightmost derivation, also multiple parse tree can be occur. If you take leftmost derivation, also multiple parse tree can occur, because one parse tree will give you addition first, other parse tree will give you multiplication first. Okay, so definitely for either leftmost derivation or rightmost derivation, two occurrences or two instances is going to be occur. Okay, so this kind of grammar is called as ambiguous. Here you see the parse tree. What parse tree you got because of plus, I mean addition, and the same parse tree you got. I mean same kind of parse tree you got because of multiplication. In case of addition, okay, in case of addition, if you start from E into E, okay, you start from E into E, then first leftmost E need to be expanded. That is E plus E. Then leftmost E has to be expanded as ID. Then middle E has to be expanded as ID, and finally last E can be expanded as ID. Here the ultimate or the alternate method. E derive E plus E. Okay. Here the leftmost E is derived as ID. There also leftmost. Here also leftmost. Try to understand. Here also leftmost ID is broken. E is expanded first, and here also leftmost E is expanded first. So E is expanded as ID. Then plus then third E is expanded as E into E, and finally middle E is expanded as ID, and last E is expanded as ID. Both are leftmost derivation. Okay, but different ways. So it leads to confusion. So that is why such kind of grammar is not accepted by either of the parts. Okay, so this is about ambiguous grammar. Tomorrow, I mean in the next class, we'll discuss how to make the grammar. I mean how to remove ambiguity from the grammar, and followed by we will discuss another type of grammar called as left recursive grammar. Once this topic is complete, then we can switch to the we can resume our previous discussion, that is top-down parsing and bottom-up parsing, right? Okay. So thank you for the day. I wish you all the best. Okay. Thank you.